Integration by partial fractions. A rational function is the ratio of two polynomials of the form px upon qx, where px and qx are polynomials in x, but qx should not be 0. If the degree of polynomial px is greater than the degree of polynomial qx, then we may divide px by qx and get a mixed form of the fraction px upon qx is equal to tx plus p1x upon qx, where tx is a polynomial in x, that will be the constant, and the degree of p1x, that will be remainder, will be less than the degree of qx. Now, if we have the integration of this rational fraction, then we have its two parts. One part is tx and it is the polynomial form, so it can be easily integrated. And now for the part p1x upon qx, we have to find the partial fraction of this by following type and then integrate it. Now, what is partial fraction? It is the method of decomposing a given proper rational fraction into a group of simple fractions, each having its denominator as one of the factors of denominator of the original rational function. So, in partial fraction of rational function is possible when the denominator can be factorized. It means denominator must have factors. And second part, the degree of numerator must be less than the degree of denominator. Keep in mind these two things. Now, first type, suppose the expression is in the form px plus q upon x minus a, x minus b. So we write it px plus q upon x minus a, x minus b is equal to capital A upon x minus a plus capital B upon x minus b, where a should not be equal to b. Then, and capital A and capital B are the constants. Then, equating these two, we can find the value of the constants capital A and capital B, and then if we will be asked for integration of such kind of function, we integrate both sides, so we get constant outside and integration 1 upon x minus a dx plus constant b outside, integration 1 upon x minus b dx. So this can be easily integrated. If there be another function like this, px plus q upon x minus a whole square is equal to, you consider it capital A upon x minus a plus capital B upon x minus a whole square. Here you see that we write capital A upon x minus a, that is the linear form of denominator, and plus capital B upon x minus a whole square, that is the square form of denominator. If there be x minus a whole cube, then what will be written? This will be plus c upon x minus a whole cube. Now there is third part. If the function is like this, px square plus qx plus r upon x minus a, x minus b, x minus c, then you write it is equal to a upon x minus a plus b upon x minus b plus c upon x minus c. Now we can find, equating both sides, the values of capital A, capital B and capital C, and then we can integrate it easily. Now the fourth type, px square plus qx plus r upon x minus a square whole square into x minus b. This is equal to, you write it, a upon x minus a linear power plus b upon x minus a whole square square power plus c upon x minus b, that is another factor. And now equating both sides, we can find out the values of capital A, capital B and capital C. Now there is fifth type, px square plus qx upon r upon x minus a into x square plus bx plus c, means linear into a quadratic form, and this quadratic form is cannot be further factorized. Then we write it like this, a upon x minus a upon linear plus bx plus c upon x square plus bx plus c. This is the method. If quadratic form is not in the form for factorizing, that means you write linear form in numerator, bx plus c upon x square plus bx plus c. Now equating both sides, you can easily find the values of a, capital B and capital C, and then you can integrate it. Now note, in case the degree of numerator is not less than the degree of denominator, the numerator is divided out by the denominator till the remainder is of lower degree than the denominator. It must be kept in the mind that always the degree of numerator must be less than the degree of denominator. We take an example. Let we have 2x plus 3 upon x plus 1 x minus 3. So we write it. This expression is equal to a upon x plus 1, one linear factor, plus b upon x minus 3, that is another linear factor. Take LCM both sides. You see denominator of both sides cancel out. You get 2x plus 3 is equal to a x minus 3 plus b x plus 1. Thus 2x plus 3 is equal to, you take x common, so it will be a plus b x. A plus b within bracket, outside of it will be x, plus minus 3a plus b. Here x will be there, a plus b into x. Now equating both sides, the coefficients of x and constant term, from left hand side 2 is the coefficient of x, and from right hand side a plus b is the coefficient of x. So a plus b is equal to 2, and constant term from left side is 3, and constant term from right side is minus a plus 3b, minus 3a plus b. So minus 3a plus b is equal to 3. So you see here some misprint. It is a plus b within bracket plus into x, and then the other part plus minus 3a plus b. So we get equating both, a plus b is equal to 3, a plus b is equal to 2, and minus 3a plus b is equal to 3. Now we solve these two by simultaneous equations. Linear equations are these two, so we can solve it. We get x is equal to minus 1 by 4 and b is equal to 9 by 4. These two are the solutions of capital A and capital B. Now we can write first 2x plus 3 upon x plus 1 x minus 3 is equal to 1 upon 4 minus 1 upon 4 x plus 1 plus 9 upon 4 x minus 3. If we are asked the integration of this function, then we can integrate it like this: integration 2x plus 3 upon x minus x plus 1 x minus 3 dx will be equal to, constant comes out, minus 1 by 4 integration 1 upon x plus 1 dx, plus constant 9 by 4 comes out 1 upon x minus 3 dx. So these part constant will be there, minus 1 by 4, and integration of 1 upon x plus 1, that will be log x plus 1, plus 9 upon 4 into 1 upon x minus 3, that will be log x minus 3 plus c. So this is the method to find the integration of such kind of functions. Firstly, we simplify the given function, making partial fraction, and then we can easily integrate it. So from above you can understand the steps.